The answer lies in the fascinating world of chemistry. It's the science that explains the very building blocks of our universe and how they interact. Chemistry is at the heart of cooking, medicine, and even the colors we see. In this whirlwind tour of general chemistry, we'll uncover the mysteries of matter and its transformations. Get ready for a journey into the heart of atoms, the magic of molecules, and the wonders of chemical reactions. So buckle up and get ready to explore the amazing world of chemistry, all in just 20 minutes. General chemistry is the study of matter and its properties. It delves into the composition, structure, and behavior of everything around us. At the heart of matter lies the atom, the fundamental building block of everything. We'll explore the structure of atoms, with their protons, neutrons, and electrons. These tiny particles hold the key to understanding how elements differ and how they interact. The periodic table, a cornerstone of chemistry, will be our guide as we navigate the diverse world of elements. Get ready to unlock the secrets of matter and discover the hidden language of atoms and elements. Chemistry is not just a subject confined to labs and textbooks. It is the foundation of our world, playing a vital role in countless aspects of our lives. From the food we eat to the clothes we wear, chemistry is everywhere. Understanding chemistry allows us to develop new technologies, solve environmental challenges, and improve human health. By grasping the principles of chemistry, we gain a deeper appreciation for the natural world and our place within it. Join us as we explore the profound impact of chemistry on our daily lives and discover how this fascinating science shapes our world. Imagine a world made of tiny, indivisible particles, so small you need a superpowered microscope to see them. These particles, my friends, are atoms, the fundamental building blocks of everything around us. Atoms are incredibly small, but don't let their size fool you. They are packed with incredible amounts of energy and are responsible for the vast diversity of substances we see in the universe. From the air we breathe to the water we drink, it all comes down to these tiny particles. Atoms are like the Lego bricks of the universe. Just like Legos can be combined in countless ways to create different structures, atoms combine to form everything we see and interact with. Now, let's dive deeper into the heart of the atom. At the center of every atom lies the nucleus, a dense core that contains two types of particles, protons and neutrons. Protons carry a positive electrical charge, while neutrons, as their name suggests, have no charge. These particles give the atom its mass and determine its identity as a specific element. Whizzing around the nucleus are electrons, tiny particles with a negative charge. They are much lighter than protons and neutrons, and occupy specific regions called energy levels, or orbitals. The arrangement of electrons in these orbitals dictates how atoms interact with each other, forming the basis of chemical bonds and reactions. It's like a delicate dance of attraction and repulsion, governed by the laws of chemistry. Now that we understand the basic structure of the atom, let's explore how these tiny building blocks give rise to the incredible diversity of elements we see in the universe. Each element is defined by the number of protons in its nucleus, known as its atomic number. For example, hydrogen, the simplest element, has an atomic number of 1, meaning it has 1 proton in its nucleus. Carbon, the backbone of life as we know it, has an atomic number of 6, indicating 6 protons. To organize this vast array of elements, chemists created the periodic table, a masterpiece of scientific organization. The periodic table is like a map of the elements, guiding us through the fascinating world of atoms and their interactions. Atoms are social creatures. They rarely like to be alone. Instead, they join forces with other atoms to form larger, more complex structures called molecules. A molecule is simply 2 or more atoms held together by a special force, the chemical bond. Think of chemical bonds as the glue that holds atoms together. When atoms share electrons, they form a type of bond called a covalent bond. Covalent bonds are the most common type of chemical bond and are responsible for the formation of countless molecules, from the water we drink to the proteins that make up our bodies. So, just like letters combine to form words, atoms join forces to create the molecules that make up our world. We meet come just to dear. Chemical bonds are not all created equal. Just as there are different ways to connect objects, there are different types of chemical bonds, each with unique properties and strengths. We've already met the covalent bond, where atoms share electrons like good neighbors. But sometimes, atoms are feeling a bit more selfish and prefer to gain or lose electrons completely. This electron exchange creates ions, atoms with a positive or negative charge, and leads to the formation of ionic bonds. Ionic bonds are like magnets, where opposite charges attract. For example, in table salt, sodium loses an electron to become positively charged, while chlorine gains an electron to become negatively charged. The electrostatic attraction between these oppositely charged ions holds them together in a crystal lattice. So, the dance of chemical bonds is a complex and fascinating one, with different types of bonds creating the diverse array of molecules that make up our world. When atoms of different elements combine in a fixed ratio, they form compounds. Compounds are like unique recipes, with each ingredient contributing to the final product's properties. Take water, for example. This simple yet essential compound is formed from 2 hydrogen atoms and 1 oxygen atom, always in that specific ratio. This combination gives water its unique properties, such as its ability to dissolve many substances and its high boiling point. Compounds are everywhere. Salt, sugar, carbon dioxide. These are just a few examples of the countless compounds that make up our world. Each compound has its own unique set of physical and chemical properties that determine how it behaves and interacts with other substances. Understanding compounds is key to unlocking the secrets of chemistry. Hold on to your atoms, folks, because things are about to get reactive. In the world of chemistry, things are always changing, transforming, and reacting. That's where chemical reactions come in, the exciting events where substances interact with each other, breaking and forming bonds to create something entirely new. Imagine a dance floor where atoms are the dancers, constantly switching partners and forming new pairs. The original substances, called reactants, are like the starting dance partners. As the music plays, they interact and rearrange, breaking old bonds and forming new ones, until they end up with different partners, the products. These transformations are happening all around us, from the rusting of iron to the baking of a cake. Chemical reactions are the driving force behind countless natural processes and human-made technologies. So, get ready to witness the magic of chemical reactions, where atoms dance, bonds break and form, and new substances are born. Just like there are different types of dances, waltzes, tangos, and breakdancing, there are different types of chemical reactions, each with its unique steps and moves. In synthesis reactions, 2 or more reactants combine to form a single, more complex product. Think of it like 2 solo dancers pairing up to perform a dazzling duet. For example, when hydrogen and oxygen react, they combine to form water, a simple yet essential compound. Decomposition reactions are the opposite of synthesis. Complex reactant breaks down into simpler products. It's like a dance troupe splitting into individual performers, each showcasing their unique style. For instance, when water is electrolyzed, it decomposes into hydrogen and oxygen gas. Single displacement reactions involve one element replacing another in a compound, like a dancer cutting in on a couple and stealing a partner. For example, when zinc is added to hydrochloric acid, it displaces hydrogen, forming zinc chloride and releasing hydrogen gas. These are just a few examples of the diverse and fascinating world of chemical reactions. Now, you might be wondering, where do all these atoms go during a chemical reaction? Fear not, for the universe has a strict rule, the law of conservation of matter. This fundamental law states that matter cannot be created or destroyed in a chemical reaction. It can only be transformed. Think of it like a game of atomic Lego. You can break apart existing structures and build new ones, but you always have the same number of Lego bricks. Similarly, in a chemical reaction, atoms are rearranged, but the total number of atoms of each element remains the same. This concept is represented by balanced chemical equations. These equations are like mathematical sentences that describe the reactants, products, and stoichiometry of a reaction. Balancing chemical equations is like solving a puzzle, making sure that every atom is accounted for and the law of conservation of matter is upheld. Get ready for a show-stopping demonstration that's sure to make you say, "Whoa, that's chemistry." Today we're going to create a reaction so big, so impressive, it's called the Elephant Toothpaste experiment. To accomplish this feat of chemistry, we'll need a few key ingredients: hydrogen peroxide, dish soap, yeast, warm water, and some food coloring for a splash of fun. Safety first, always. Before we begin, remember to wear your safety goggles to protect your eyes. Now, let's gather our materials and get ready to unleash the power of chemical reactions. First, we'll mix our hydrogen peroxide with some dish soap and a few drops of food coloring in our trusty beaker. Give it a gentle swirl to combine the ingredients, but no vigorous shaking. We don't want to trigger the reaction prematurely. In a separate container, we'll activate our yeast by dissolving it in warm water. Yeast, a tiny fungus, will act as our catalyst, speeding up the decomposition of hydrogen peroxide. Now for the grand finale. With anticipation building, we'll carefully pour the hydrogen peroxide mixture into the bottle containing the activated yeast. And voila! Like magic, a foamy fountain will erupt from the bottle, cascading outwards in a mesmerizing display of chemistry at play. So, what's the scientific wizardry behind this foamy spectacle? It all boils down to the decomposition of hydrogen peroxide. When hydrogen peroxide breaks down, it forms water and oxygen gas. Yeast contains an enzyme called catalase, which acts as a catalyst, providing an alternate pathway for the reaction to occur more rapidly. As the hydrogen peroxide decomposes, the released oxygen gas gets trapped by the dish soap, creating countless tiny bubbles that make up the impressive foam we see. The food coloring simply adds a visual element to the reaction, creating a vibrant and captivating display. The Elephant Toothpaste experiment is a fantastic example of how chemistry can be both educational and entertaining. Let's take a moment to recap the incredible journey we've taken through the world of general chemistry. We started with the tiniest particles, atoms, the fundamental building blocks of matter. Remember, atoms are incredibly small, yet they hold the key to understanding the vast diversity of substances in the universe. We delved into the structure of atoms, exploring the nucleus with its protons and neutrons and the orbiting electrons that determine an atom's personality. Understanding atoms is crucial because they are the foundation upon which everything else in chemistry is built. So, as we move forward, let's keep in mind the incredible importance of atoms, the unsung heroes of the chemical world. Molecules. Building blocks of complexity. Moving up the ladder of chemical complexity, we encountered molecules, two or more atoms joined together by the glue of chemical bonds. Molecules are where things get really interesting because they are the building blocks of the substances we interact with every day. We explored different types of chemical bonds, from the strong and stable covalent bonds to the attractive forces of ionic bonds. These bonds, formed by the sharing or transfer of electrons, determine the shape, properties, and reactivity of molecules. Just like letters combine to form words, and words combine to form sentences, molecules combine and interact to create the complexity of the world around us. From the water we drink to the proteins that make up our bodies, molecules are the workhorses of chemistry, carrying out essential functions in every living organism and non-living substance. So, as we continue our chemical exploration, let's appreciate the intricate world of molecules and their vital role in shaping our universe. Chemical reactions, the heartbeat of chemistry. But the real magic of chemistry lies in the dynamic transformations that occur during chemical reactions. These reactions are the heartbeat of chemistry, constantly reshaping and rearranging matter, breaking old bonds and forging new ones. We witness the power of chemical reactions in the awe-inspiring Elephant Toothpaste experiment, where hydrogen peroxide decomposed rapidly, releasing a torrent of oxygen gas and creating a dramatic eruption of foam. This visually stunning demonstration highlighted the energy changes and transformations that accompany chemical reactions, from the simple act of striking a match to the complex processes of photosynthesis and cellular respiration. Chemical reactions are the driving force behind countless natural phenomena and technological advancements. They are the engines of change, constantly transforming our world at every level. As we conclude our whirlwind tour of general chemistry, remember that it's not just about static molecules, but about the dynamic interplay between them, the constant dance of reactions that makes chemistry come alive. The power of chemistry. As we've journeyed through the fascinating world of general chemistry, we've uncovered the fundamental principles that govern the behavior of matter. From the tiniest atom to the largest molecule, chemistry is the invisible force that shapes our world, connecting us all in a grand symphony of interactions. We've seen how atoms, those minuscule building blocks, combine to form molecules of astounding complexity and diversity. We've witnessed the power of chemical bonds, holding atoms together in intricate dances of attraction and repulsion, giving rise to the substances that make up our universe. And we've marveled at the dynamic nature of chemical reactions, those transformative events where bonds break and reform, substances rearrange, and new compounds are born. It's through these reactions that chemistry comes alive, constantly reshaping and refining our world. Understanding the principles of chemistry empowers us to see the world with new eyes, appreciating the interconnectedness of all things and the elegant simplicity underlying the complexity we observe. A world transformed. Chemistry is not just an abstract science confined to textbooks and laboratories. It's the driving force behind countless innovations that have transformed our world and continue to shape our future. From the life-saving drugs that combat disease to the high-tech materials that power our devices, chemistry is at the forefront of advancements in medicine, technology, and countless other fields. It's through the ingenuity of chemists that we can develop new energy sources, create sustainable materials, and address pressing environmental challenges. Think about the clothes you wear, the food you eat, the car you drive. Chemistry plays a vital role in their production, from the synthesis of synthetic fibers to the development of fertilizers that boost crop yields. Even the air we breathe and the water we drink are subject to the principles of chemistry, as we strive to maintain a healthy and sustainable environment. By understanding chemistry, we gain a deeper appreciation for the ingenuity of human endeavor and the remarkable potential of science to solve problems and improve our lives. Keep exploring the chemistry around you. As we conclude our whirlwind exploration of general chemistry, I encourage you to carry a sense of curiosity and wonder with you. Chemistry is not just a subject to be studied, it's an invitation to explore the world around you with a fresh perspective. The next time you bake a cake, notice the chemical reactions transforming simple ingredients into a delicious treat. Observe the vibrant colors of autumn leaves, a result of chemical processes within the plants. Marvel at the complexity of a single drop of water, a testament to the power of chemical bonds. The world is your laboratory, filled with endless opportunities to observe, question, and discover the wonders of chemistry. Embrace your inner scientist and never stop exploring the fascinating world that surrounds you. Remember, chemistry is more than just equations and formulas. It's a journey of discovery that can ignite your imagination and inspire a lifelong love of learning.